for today's lecture, we will be having the third of the four applications of differential equations. So this third one is called the mixing tanks or chemical solutions. This one, let's just take this figure as a tank. Let's just say it's a mixing tank, and then this one is a stirrer. This is a continuously stirred tank. So let R1 and C1 be the streams going in, R2 and C2 be the streams going out. So what are the R, C, etc.? So let R be the flow rate, C be the concentration of the stream going inside, V is the volume, and then X or Y is the solute concentration or the amount of solute, and then T is time. So let's go to the units. Typically for the flow rate, we use gallons per minute in here. But of course, you can have other units like liters per minute, liters per hour, right? Or milliliters per second. But then typically, for our convenience, I'll be using gallons per minute. For concentration, I'll be using pounds per gallon. And then the volume is in gallons. And then in here, some use either Y or X to represent the amount of solute. So that's in pounds. But in this differential equation, Y was being used. So I can say that the concentration, is it correct? Pounds per gallon?
Gallons, sir.
Gallons. And then the time that we're using is?
Minutes.
Change in the amount per time. You're right, pounds per minute. So in here, I could say that concentration input is constant. And then the rate here, we would assume that it does not change also. So it's constant. So C1 times R1. The problem, guys, is that the rate number 2 does not change, but the concentration number 2 changes with time. So the C2 here, we know that C is always Y over V. But we know that change in volume with respect to time, gallons per minute. But what is the unit of R? Isn't it that R is gallons per minute? Is equal to R1 minus R2 dt, and then you integrate that. You integrate this from V sub 0 up to any volume, and then this is T sub 0 up to any time. So that T sub 0, of course, let's just say that's time equals 0. So you can say here, V minus V sub 0 is equal to R1 minus R2 times T. Or we can safely say that V is initial volume plus R1 minus R2. So it only shows here that the change in volume with respect to time is basically the differences in the flow rates. Okay, so let's take this as an example. So let's try to visualize it. So it says there that there is a tank. Let's just say this is a tank. And then initially, the tank does not have any salt because it's pure water. It contains 100 gallons of pure water as it says here. So that means Y sub 0 is 0. It does not contain any salt. And then what comes in? Rate number 1 is 3 gallons a minute. And then what goes out? 2 gallons a minute. But we don't know the initial concentration of what's coming in. Although we know that at time equals 20 minutes, the concentration of that in the tank is 2 pounds per gallon. So can I say, guys, that at time equals 20 minutes, whatever the concentration of the tank is, that is also the concentration of the liquid flowing out. So I can say that the concentration inside the tank is not constant, right? It would always help if you try to draw. It doesn't matter if you don't draw it nicely. It's just that, with me, I just try drawing it. Yeah, so it contains certain liquid. So what comes in and what goes out? So, okay, what comes in? R1 and C1. What goes out? R2 and C2. And then what's required, guys? Isn't it that the required is C1? Okay, let's try to label what is given. What was the initial? You know that's 3 gallons per minute. This one is unknown. This one is 2 gallons per minute. Okay, and then this C2 is just C2. Let's just leave it like that because it changes. Okay, what else do we know? We know that at time equals 0, you can say that V initial is 100 gallons of pure water. What else do we know? That initially, there is no salt. 0 pounds of salt in the solution. So that is the initial consideration. Let's just say that one. Now, what else is given? There, time equals 20, the concentration is 2 pounds per gallon. So I can see that concentration at 20 is equal to 2 pounds per gallon. So this is at, time equals 20. So I'm just rewriting it. That 20 there is actually this 20 here. Okay. So let us start with the solving. Let's start with number 1. With me, typically, I would look at these two. Look at this. This one and this one. Basically, you just have 2 differential equations to work with. So the first one, let's just say dv over dt is equal to rate number 1 minus rate number 2, adding in minus out. Therefore, I can say that dv is equal to r1 minus r2 dt. And then if you want to integrate this, let's integrate this one from initial volume up to final volume v. This one up to from initial time, which is time equals 0, up to final time t. Okay. Therefore, v coming from 0 to final is equal to r1 minus r2 t from 0 to t. Therefore, v minus vo is equal to 3 minus 2. This one you can just say t, right? And then initially, you are given an initial volume, right? Time equals 0, v is equal to 100 gallons. So you can safely say that your volume at any time is always 100 plus t. Let's just say this is equation A. Let's go to the second equation because there are 2 working equations in mixing tanks. The second working equation, let's go back here. dy over dt is in minus out. So C1 R1 minus C2 R2. dy over dt is equal to input, which is C1 R1 minus C2 R2. Okay, let's try to input whatever we have at the moment. Are we given C1? We don't know what C1 is. Let's just write that as C1. We know what R1 is. That's 3. Do we know C2? We don't know. The C2 changes with time. So let's just write that as C2 for the meantime. Do we know R2? Yes, that's 2. We know that C2 changes with time, as I have been saying earlier. So let's take note. C2 is a function of time, right? It changes with time. So what we know about that is that earlier I said concentration is equal to Y over V. And then the Y is any any y. We don't know what y is, but we know that the v all the time is 100 over t. Let's just say this one is letter B for C2. This C can be C2. That's any concentration. So here, what I would have is dy over dt is equal to 3 C1 minus 2 y over 100 plus t. Or if I rearrange this, you know earlier I said that C1 is constant. If I rearrange this equation, I'll just fix it. 100 plus t. Take note that C1 is constant. Note that C1 is the constant input concentration. So this is linear in y. Okay, this equation here. Okay, but let's try to solve now. If we know that that's linear, let's try solving. Again, let's rewrite that first. dy over dt plus 2 over 100 plus t y is equal to 3 C1. All right, that's correct. So in linear, what are the parameters that we need? Isn't it that I need a P of t, Q of t, and then the integrating factor? What's the integrating factor? E to the integral of pt dt, 2 over
100 plus t.
What about qt?
3C1.
That's 3 C1. And then this is e to the integral of 2 over 100 plus t dt. Okay. So let's try solving this first, the integrating factor. What will that be?
ln 100 plus t.
E to the
ln 100.
2 ln of
100.
100 plus t, right? So if we solve this, can I safely say that this one is basically 100 plus t quantity squared? Try to recall that for linear, what will that be? Y times the integrating factor is equal to the integral of qt times the integrating factor d 100 plus t quantity squared is equal to the integral of qt is 3 c1. The integrating factor is 100 plus t squared dt. So when I integrate the right side, I can move out the 3c1 because those are constants. This becomes 100 plus t to the third power over 3. But then take note, this is an indefinite integral. So you will have to have a c. Okay? So let's try to fix this. 100 plus t squared, this just becomes c1 100 plus t cubed plus c. So this is our working equation now. This is what you call the, this is what you call the general solution. But the problem is, are we given any initial conditions in here? When time equals 0, the volume is 100 gallons. The y at 0 is basically 0 pounds. Am I correct? So maybe we can try to plug in whatever we need. So 0, 100 plus 0 squared is equal to C1 100 plus 0 cubed plus C. So I'm able to solve for C is negative 100 cubed C1. Therefore, I can say that my working equation now is y 100 plus t squared is equal to C1 100 plus t cubed minus, let's just say C1 100 cubed is 1. Let's rewrite that here. Y 100 plus t squared is equal to C1 100 plus t cubed minus C1 100 cubed. Okay. Are we given anything else? Can we check? Let's see. Are we given anything else apart from this? What have we not used so far? Time equals 20 minutes. C at 20 is 2 pounds per gallon, right? Remember that C is equal to what? Y over V. And then earlier, I showed you that equation A, V is equal to 100 plus T. That one, when we plug that in here, what is the volume daw at 20 minutes, guys? 100 plus 20. So, 120 gallons. Am I correct? Right? So, using the first equation, the equation above, C is equal to Y over 120. But we know that C at 20 minutes is equal to 2 pounds per gallon. So 2 is equal to Y over 120. So I can say that Y is 240 pounds. So now that we have 240, I can say 240, 100 plus, the times 20, right? All right. 120 squared is equal to C1. We don't know. That's what we're looking for. Plus 20 cubed minus C1 100 cubed. So this is 120 cubed C1 minus 100 cubed C1. This is 240, 120 squared. Can you please check?
4.747.
So roughly, I could say, what is the unit, guys, of C?
Pound per gallon po.
Pounds per gallon. So, let's say this one. So that means 4.75 pounds per gallon is your initial. Now, let's try this one. All right. So let's go to the figure. So you have initially a tank. It was CO, it's VO and YO, meaning it's initially contained already. 200 gallons of water, 50 pounds of salt. So this is a 300-gallon tank. And then initially, it already contains some liquid. So the initial, I typically just put it here. Initial volume ko was 200 gallons. And then initial amount of salt ko is, how much was said, guys?
50, sir.
50 pounds. Okay, so let's go. R1, C1, R2, C2. So let's put the arrows there. Okay. You're given
4 gallons per minute.
4 gallons a minute. All right. Sorry, 4 gallons a minute. Yeah. And then this one is 3 pounds per gallon concentration, 3 pounds per gallon. And then this volume total, I'll just say volume total is 300 gallons. But then it's not full yet. The rate coming out is 2 gallons a minute. All right. This one is just C. It's any concentration. Now, all right. So I can safely say that these ones are the initial. I'll just label that as time equals 0. Okay. So, ito, 200 gallons of water and 50 pounds of salt. I'll just label them. Okay. So you're asked A, what is the concentration at time equals 30 minutes? You're asked letter B, when will it overflow? Volume. So the time is the one that's being asked. And letter C, what's the amount of salt in 60 minutes? So Y at 60 minutes is unknown. Okay. Where will I get my equations from again? Number 1, saan ulit guys? So I can say here that dV over dt is equal to rate 1 minus rate 2, right? dV is equal to 4 minus 2 dt, or I can say that dV is 2 dt. So let's integrate this. Zero to time, this is V naught up to V. Therefore, this one is V from V naught up to V is equal to 2t from 0 to t. It so happened lang that my V naught is given. It's 200. It's equal to 2t. Therefore, V at any time is 200 plus 2t, right? So let's just say this is equation A coming from number 1. Okay, what's our second working equation, guys? Where do we get it from? We only have 2. One is the volume, the other one is, so dy over dt is equal to C1R1 minus C2R2. Let's try to plug in whatever we know first. We know what C1 is. It's given 3. We know what R1 is. It's 4. We don't know what C2. It's always unknown.
2.
Okay. So this is 12 minus 2. C2 is dy over dt. However, we can solve for C2. Okay. So we can say that C y over v. Y, let's just leave it as y. What about the v? Isn't that 200 plus 2t? So this one becomes dy. So let's just call this pala, this one equation B. So ito, plug in natin yung equation B and C. So that one is actually your C number 2. So this is 12 minus 2 y over 200 plus 2t. Now let's try to simplify because we can still simplify this. Right? Is this correct? dy over dt, right? Or if you want to fix how it looks like, one over 100 plus t, y is equal to 12. So linear in y. Now let's try to rewrite that. dy over dt plus 1 over 100 plus t times y is equal to 12. P of t, q of t, e to the integral of et dt, right? This is your integrating factor. 1 over,
100 plus t.
all right. What about qt?
12.
12. So this is e to the integral of 1 over 100 plus t dt, which gives us e to the ln of 100 plus t, which can be simplified as 100 plus t. So let's write the general solution for this. The general solution is y times the integrating factor, integral of q t times the integrating factor dt. Y
Y
times,
qua- times quantity of 100 plus t
all right,
was qt is 12 times integral factor, a quantity of 100 plus t times t.
all right. So if I integrate this, the right side, I'll end up with 12 100 plus t squared over 2 plus constant. Am I correct? Or if I would fix this, this is actually 6 100 plus t squared plus c. So that is actually your general solution already. So I'll just erase that. I'll put that here. So this is your general solution, right? What are the initial conditions? When time equals 0, what was the initial volume?
200 gallons.
200 gallons. What was the initial concentration or initial Y given?
50 lbs.
50 pounds, right? Therefore, when we plug that in, 50, 100, 6, 100 squared plus C. So can you please do this for me? What will be the answer? Minus 55,000. Y 100 plus T is equal to 6. 100 plus T quantity squared minus 55,000. So this is my working equation. But then we haven't answered the question. The question was, how much salt is there after 30 minutes? So in order to answer that, y at 30 minutes, so we'll use the equation y 100 plus t is equal to 6 100 plus t quantity squared minus 55,000. So y, this is 130, 6, this is 130 squared minus 55, 356.92.
92.
So I can safely say that y is 357 pounds of salt at the end of 30 minutes. Okay, that one. Now, you're being asked letter B. Ang question letter B is, when will the tank overflow? So letter B, time. The total volume of the tank that it can hold is 300 gallons. Okay, do we have an equation for the volume? Using equation A, using equation letter A, wherein that is V is equal to 200 plus 2T. So this is 300 is equal to 200 plus 2T.
50.
So that means at 50 minutes from the start, it will overflow. Right? So what happens, guys, is this. At time is less than 50 minutes, here is what's going to happen. R1, C1, R2, C2. Now, when time is greater than or equal to 50 minutes, that's when it starts overflowing. So, it's continuously stirred. So I can say R1, C1, I'm sorry, I'll just put the C1 below. This is R2, C2. But because it's overflowing, you can see that there is already R3, C3. Note that for time is less than 50 minutes, Y 100 plus T equals, yan siya, 6, 100 plus T squared minus 55,000 was our working equation. So for salt, kasi look at this, what's being asked in letter C? How much salt is there after 60 minutes? Yun hindi natin alam. So in order to solve for that, to solve for letter C, at 50 minutes, I can say 100 plus 50 is equal to 6. 100 plus 50 squared minus 55,000.
533.333
pounds. Salt, tama? That is at 50 minutes. For time is greater than or equal to 50 minutes, what's happening is that the one I showed you earlier, this is a continuously stirred reactor. Rate 1, concentration 1. Rate 2, concentration 2. Rate 3, concentration 3. Right? Okay. Isn't it that volume at time t is equal to what? All the time, volume plus R1 minus R2 times T. Yes, this is volume at any time. Pero ang tanong ko, kapag ka ba after 50 minutes, what is the volume?
So
Am I
it's
correct?
still 300.
Yes, volume is always 300. In this case, the V is equal to VO is equal to V max, which is 300 gallons because it is already overflowing, right? R1, C1. What are the outputs?
R2C2.
R2C2 minus also R3C3.
R3.
So anything that comes in, guys, is positive. Anything going out, negative. Okay, let's plug in R1. What is the R1 again? It was given as 4 times 3. R2 is given as 2. C2 we don't know yet. But we know that R1 R2 plus R3. So if R1 is 4, R2 is 2, you know that R3 has to be, okay? So that means R3 is also 2. And all the time, the volume is 300 as stated there because, it's always V max. So Y over 300, Y over 300, right? 12 minus, this one is 4, 4Y over 300, or dy over dt, right? Plus 4 over 300, am I correct? 1 over 75 is equal to 12 dy over dt, 1 over 75y is equal to 12. So linear pa rin naman siya. Walang problem. Kailangan ko ng pt, qt, and e to the integral of pt dt. pt is 1 over 75, no problem. qt is 12. E to the integral of 1 over 75 dt, right? So this is simply e to the 1 over 75 t. Tama, hindi siya magiging ln kasi wala namang t sa ilalim. Okay. Therefore, y e to the 1 over 75 t is equal to the integral of qt 12 times e 1 over 75 t dt. So 900 e to the 1 over 75 t plus c. So this is your general working solution. You're asked to solve for y 60 minutes. We don't know that. You have to remember that tank starts to overflow at t is equal to 50 minutes, right? Therefore, time equals 60 is actually equal to 10 minutes relative to 50 minutes. That 60 minutes is actually just 10 minutes after it overflows. Time equals 0. This is actually at the 50-minute mark already. Y equals 533.33 pounds. Let's just say this is the star. Ito yun. Can you understand, guys? Alam ko nakakalito, pero can you understand? Na ang gusto kong isolve is, ang gusto nating isolve, di ba, is this one. What is yung C? What is the Y at 60 minutes? That's what we're solving for. Kaya lang, para ma-solve mo yung 60 minutes na yun, ang problema kasi nag-overflow na eh. So, isolve mo muna, bago ba siya mag-overflow, ilan ang laman niya? So, 533.33. Now, after it overflows, gaano katagal ba yung 60 minutes? It's another 10 more minutes. Can you follow? So that means, kunin muna natin yung constant nito. Kasi lagi naman kinukuha natin yung constant eh. Right? So, 533 E 175 times 0 is 900 E 175 times 0 plus C. What is my C, guys? This actually cancels out. This is 1. This is 1.
Negative 366.67.
7. Therefore, the actual working equation pala is y e to the 1 over 75 t is equal to 900 e 1 over 75 t minus 366.67. Now, when time is equal to 10 minutes, this is the actual 60 minutes because 10 minutes, this is actually after it has overflowed. So, you're actually solving for y60. This is when y is equal to 60. So, let's solve y e to the 1 over 75 times 10 equals 900 e 1 over 75 times 10. Sorry.
Sir, 579.10.